Hello and welcome back to Software Engineering Daily. My name is Mike Bifulco, one of the co-hosts of the show. Today I'm sitting down with some new friends to talk about a cross-industry, pretty broad-spanning project that addresses one of the most fundamental sort of features and protocols that the internet uses. I'm sitting down today with Nick Shadrin and Roman Arutyunyan to talk about the HTTP3 protocol. They're both NGINX employees, but have been working on HTTP3 and software that will affect sort of everyone building on the internet eventually at some point. And so the goal today is to kind of chat about HTTP3, hear about the protocol, hear about what's going on there, and to get a better understanding of why this is such an important fundamental building block for the internet and the future of communication for the world, and to get into some of the nitty-gritty details of building protocols that will be broadly used. So let's start here. Nick, Roman, thanks so much for joining me today. Why don't we go through a quick introduction? Nick, why don't you start? Can you tell us a little bit about yourself and how you got to NGINX?
Absolutely. My name is Nick Shadrin, and I currently work as a software architect for NGINX. And I've been with the company for about almost 10 years now and did a lot of different technical tasks from the times when NGINX was a startup. So right now I do a lot of work related to the management planes around NGINX and also working on promoting the different new protocols and new features of the data plane.
Fantastic. Well, appreciate having you joining here. It sounds like you're exactly the right person to be having this conversation with, alongside Roman. Roman, why don't you give us the quick introduction as well?
Thanks, Mike. Thanks for having us. My name is Roman Arutyunyan. I am a developer at NGINX. I've been with the company since 2014 officially, and before that I was a contractor. And before that I wrote some third-party modules for NGINX. So I was engaged in pretty much everything in NGINX development, both NGINX open source and NGINX Plus. But lately I was mostly concentrated on NGINX open source and particularly HTTP3 and Quick.
Yeah, that's great. Well, that's definitely tees up an interesting conversation for us today. I have quite a bit of history of building for things on the web, and I think I've been an end user of NGINX in many ways over the years. But believe it or not, it's something that I haven't had to use directly or configure directly too often. And I think maybe a good way to start this conversation, although we're not talking about NGINX specifically today, is to kind of set the stage with like what NGINX is and what it's for, and maybe the like NGINX 101, like explain why NGINX is a product, why it's interesting, who uses it, and then how this sort of tees into the conversation around protocols and HTTP.
NGINX started as a web server project to solve some specific performance issues of just very few special projects of the developer who started it. But then when he started implementing NGINX in his and his friends' environments, it took off as a very popular project. It was built very well. And one of the major things that NGINX does is not taking somebody else's libraries or somebody else's ready code, but rather developing the fundamental features straight into the product, straight from the software itself. And right now, NGINX is taking a very large percentage of the internet traffic, a huge number of internet domains, and it is a very popular project.
Yeah, I think that's probably why it's a familiar term to many people who've built things for the web for so long. I think the fact that it's a web server that was built from the ground up and sort of purpose built is a very interesting story, especially in like a modern web where everyone's grabbing kind of the Lego brick that they need for everything under the sun, from NPM or Ruby gems or Python libraries, whatever the case may be. So maybe we can start here as well. If you're just kind of getting started with NGINX, like what's the hello world for NGINX look like?
Let me talk about it. It depends on what you mean by hello world. If you mean a developer's hello world, that's a C module, which can, if you access NGINX with HTTP protocol, it returns you the hello world string. it's not so complicated, but it's rather complicated. And so the entry level for NGINX development is pretty high, I would say, and that's why we had several development trainings, and we have some documentation on NGINX development. So yeah, that's it.
Developing a C library for Hello World for NGINX is kind of just responding to an HTTP request to deliver a 200 response with Hello World in it. Is that more or less the idea here?
Yes. The idea was to develop a very fast HTTP server.
Yeah.
And over time, the functionality grew. Now NGINX is well known for its proxy capabilities and for caching. Although it's way more than that. It's a stream meaning TCP and UDP. Proxy, it's a mail server, mail proxy. It can serve static files. It can do video streaming also, especially the NGINX Plus version. So
it's well engineered to handle an incredible amount of complex stuff that I think a lot of web devs just sort of rely on the functionality of, rather than really deeply understand the nuts and bolts of it under the hood. So that's a bit about NGINX 101, but what makes a good user of NGINX?
This is a very important question, because you mentioned that you are an NGINX user and you've been at some point, and probably people who are watching this using some of the services are also users of NGINX, since they're using our technology. But also the sysadmin, the operator who configures NGINX, is also an NGINX user, but in a different sense. And for NGINX engineers, some people would say that people who configure websites and make websites that work with NGINX are engineers for NGINX. But also contributing to the actual code base of NGINX is NGINX engineering. So when you're saying what's an NGINX user and what's an NGINX engineer, it's always better to be specific, that we're saying the end users of the website or web application, or the sysadmins, operators who configure it, or engineers who make the websites behind NGINX, or engineers who make features for NGINX. Those are 4 different types of people who deal with this.
Yeah, I think that's maybe why it feels like such a household name too. Like there's a broad array of reasons that you might hear whispers of NGINX in your world, depending on your framing and your focus. It's clearly something that enables quite a few important workflows for the internet, and especially for just like communicating with a modern web stack across the web, between your applications and APIs and things like that. Yeah, it's good framing. And I think for the purposes of this discussion, it's also a good reminder that the audience of this podcast are pretty broad too. So we have lots of folks who listen to the show who may be front-end developers or live primarily in like machine learning world or, API devs, things like that. And so we'll kind of do our best to give some background on the things that go into the building blocks of what we're talking about here. And maybe that's a good place to start talking about HTTP. So why don't we talk about the HTTP protocol in general and what it is and what it does? Can you maybe give a brief description of what HTTP is on a 100 level?
I can talk about that, definitely. HTTP is a very simple protocol that enables a very standard communication that has a request for something and a response from the server. In the very normal understanding of HTTP, it's basically we're getting a URL by issuing a very simple request, let's say get / and then that's the main page of something. And as a response, we get the response code, which says everything's okay, and we start receiving the content of that page. This is the very, very basic part of that. And on top of this, standardized communication, we have a lot of other modifications to that simple request. We can post information to the server, we can send something to the server, some data, and the server can be responding not just with very nice and easy and proper content, but also might send some errors or some commands for that client to do something else. And that protocol is very well known in the web.
Yeah, it goes back pretty far too, right? HTTP is something that's existed for quite a long time at this point.
Exactly. It's beginning of the 90s when it became basically the main protocol of the web.
Yeah. So since the 90s, then how has it grown? I know we're talking about HTTP 3 today. What was the step in between? What did HTTP 2 represent in terms of changes?
Well, the first version of the protocol, that was the very basic and plain text version of that. And then the people and the standards organizations started adding things like encryption, caching, different headers, different ways of operating with sub protocols like WebSockets and so on. But in the somewhere, and that was going all the whole decade of the 90s. Around beginning of 2000s and towards 2008, 2012, there was a few performance problems because of the growth of the web, because of the growth of the web pages and all of those systems. The community found a number of performance issues with that. And one of the major attempts of solving that was made by Google when they created the protocol called Speedy. It's pronounced as SPDY. That's the modification to the HTTP protocol that enables a lot of requests going through the same connection without establishing more connections for those requests. And then at some point, a couple of years later, it was standardized as HTTP2 with some more modifications to the protocol that was called Speedy. So basically, it's not for HTTP2 or for the same reason HTTP3 or HTTP1, they're not proprietary standards. They're open. Anybody can do whatever they want according to that standard. And it is suggested that the vendors of the software will follow those standards. With HTTP2, browsers tended not to use the unsecure version of the protocol. And another thing about that is HTTP2 also allowed compression of the headers of the protocol. Those are very important security features. And I'm sure Roman can add a few other things about HTTP2 that he knows very well.
Let me start actually from HTTP, from the early versions of HTTP. The first HTTP version was first widely known is HTTP 0.9, which was very simple. It worked over one TCP connection. It had a very simple request, one line, and then the response was just everything that was sent back. So very basic protocol. The next one was HTTP 1.0, which had like a request with headers and response with headers. It worked very well, except we need for every client request we needed a round trip because we need to establish a TCP connection. Okay, so as internet grew and as web grew, we needed a more efficient protocol. So then in late 90s, HTTP 1.1 was introduced, which partially addressed this issue. HTTP1, its main feature was keep alive. So you could send multiple requests over the same TCP connection. So you no longer needed to have multiple handshakes if you wanted to retrieve multiple files, right? So it was a way more efficient. But of course, if you have two files, you fetch one file and then the other one. While you're fetching the first one, you cannot fetch the second one, right? You have to wait. Mm-hmm. That's what they call head of line blocking. That's not good. But we saved some time on round trips because we only have one TCP handshake. And actually, as time went by, there was another reason for saving time on handshake because SSL, now everyone is using SSL or TLS because almost all connections in internet are encrypted, right? So TLS level introduces 2 more round trips. So establishing a new connection is even more expensive now. So we have to reuse the connections as long as we can. And HTTP 1.1 kind of addressed this issue, but not good enough. So then HTTP 2 came around, which was even better. It allowed you to request and receive multiple requests at the same time, because it could multiplex the pieces of requests back and forth. And so it was an application level. It is an application level protocol, but it kind of was a little bit of transport in it.
Mm-hmm.
Yeah, but it was not perfect either, because if you lose one, it's still over TCP. If you lose one piece, if you say you send two responses for two requests to the client, and if you lose one packet that carries the first response, but you receive the second packet with the second response, you still can't use it. You still have to wait until the first packet is retransmitted, because TCP is sequential. And that's why in just recently HTTP3, well, it's not HTTP3, it's actually QUIC and HTTP3 were introduced. It's finally they split the transport part and the application part in two different protocols. But everything that's about transport, the transport part is QUIC. And the application part, which is quite easy, and it's very similar to HTTP2, is called HTTP3. Yeah, and I think we'll later talk more about more details of QUIC and HTTP3, right?
Yeah, definitely. I think we're tipping our hands to some of the exciting things that are coming along with HTTP3 and why. We'll probably hear about like the companies that may already be digging into HTTP3. You can imagine sort of the benefits that'll come with it. So this is, I think it's an important thing to note that this is like the industry relies on these protocols because everyone uses it. Vendors who build application layer stuff, database layer stuff are all using HTTP to communicate just as well. Your web browser, your phone, anything that communicates with the internet uses a standard shared protocol for that. At the same time, you're both employees of NGINX. And this sounds like maybe a larger problem than that. This is like a cross-industry thing where we need buy-in from everyone there. So can you give a little more context on who is working on the development of HTTP as a protocol?
Yes, there are definitely multiple companies who deal with that, and different projects are working on HTTP. I would definitely, other than NGINX, I would definitely name the company, call them out, the company called Google, who is making a lot of efforts on modernizing the protocol for different reasons. And Google has a very interesting and very unique situation where they own their own infrastructure. They have their own clouds. They have a huge presence on YouTube, Google websites, Docs, and whatever other parts of Google ecosystem there is. But also they have the mobile operating system and the browser, Chrome. And that means that Google actually is able to make modifications to the infrastructure and also to the client side. They're able to test a lot of that using very large numbers in the load, very large number of users, very high number of requests, and some insane amounts of traffic. So I would call them out as one of the primary developers of new protocols and experiments around the protocols. As far as what NGINX does, we have a significant, very huge presence in the web server market, but we don't do the client traffic. We don't do the client part of that, as the browsers, the libraries that would be using the protocols, and whoever would be requesting data from us. So NGINX only does the server side of things, and we are not related, or we are not dependent on what Google does. We're following the standards, and NGINX is that piece of software that can be used either inside of Google Clouds or actually outside of that, using your own infrastructure or your own machines, or when you're building your own systems, like a number of different CDNs who actually have NGINX as their primary web serving component.
Yeah, and so the that's one of the values of it being a standardized protocol is that you can rely on multiple vendors to kind of keep each other in check and make sure that the protocols are being developed in parallel in a way that's mutually beneficial. Although certainly there are some stakeholders that are larger than others. There are other companies participating and other individuals participating in the development of the standard as well, right? It's a broader cross industry thing that welcomes feedback and that sort of a thing, correct?
Yeah, absolutely. And also about Google, I want to add that the initial version of Quick was an internal Google project called GQuick, and they didn't even talk about that a lot. But yeah, they implemented it in Chrome and on their servers, and they used it way before Quick as a standard showed up. So
yeah, it's an interesting use case that they're able to build both ends of it to test both from the browser and their communication protocol.
They have both the client and the servers, the most popular service. Yeah.
So we mentioned HTTP 2 came around in the 2010s, 2010s, maybe the early years of 2010-ish, call it 2010 to 2012, whatever that may be. HTTP 3 has been coming along since then. Is it useful now?
I would say that big companies like Google, Cloudflare, Facebook, they use HTTP now. So the share for the protocol is around 25% because it's mostly because of those huge companies. But I would say that smaller companies are still maybe not using it as much because the protocol is in the early stages of adoption. So I think it will take a little while.
Yeah.
We will definitely talk. We will definitely talk a lot about why there are some challenges in adopting HTTP 3 compared to HTTP 2 and other protocols. But before we do that, I think it makes sense to mention the major differences of the protocol HTTP 3 versus 2 and 1. Does it make sense to go in that direction?
Yeah, please, definitely. That sounds great.
Mm-hmm. And since we already started talking and kind of mixing together HTTP 3, 2, and 1, we'll mention the main difference there. So HTTP 3 and Quick is based on UDP traffic. From the transport level and from the sysadmin level, from the operations of all kinds of devices around the protocol, having the different transport system is a very big deal. Basically, everything in the world is optimized for TCP traffic in the sense of web. And we know how to deal with the TCP connections really well. But now we need to open different ports and look at the different types of traffic from the point of view of the networking. All of those boxes in between, they need to properly understand that UDP connectivity, the UDP connections.
Yeah, and they need to be able to relay information between using the different protocol. So UDP and TCP are similar but different in some important ways. What's the basic difference between the two?
Yeah, UDP is packet-oriented. UDP is basically is all about sending one datagram from this computer to that computer, and nothing more. But TCP is connection-oriented, which means you establish a connection and you send a packet and you expect an acknowledgement for that packet. If the packet is not acknowledged in the expected time, you retransmit the packet. So it's a reliable protocol.
Yeah, so I suspect I may be oversimplifying it a bit, but it sounds like TCP requires like the two computers A and B talking back and forth a lot more. They're sending and acknowledging, sending and acknowledging.
And again, the handshake takes some time. Okay, and the problem with Quick is that Quick is built on top of an unreliable UDP protocol. So everything about establishing the connection, everything about retransmission, it all should be implemented in Quick. That is in user space, because typically TCP is implemented in the kernel. And Quick is, maybe this will change in the future, but so far it's all in the user space. That has its own consequences, by the way.
Yeah, so the developer story must change a little bit there too. I suspect we'll talk about that a little bit coming up here. I guess at some level, HTTP3 relies on UDP a whole lot more, and Quick as a result has kind of come around because of that. What are some of the other sort of basics of HTTP3?
Okay, I can cover the main parts of that. So apart from being based on UDP transport, one of very important things there is how the encryption got implemented in the protocol. If we look at the standards of HTTP1, it doesn't talk about encryption much or at all. In HTTP2, it is possible to send unencrypted HTTP2 connections, but the browser systems, the browser developers chose not to do that. So HTTP2 in practice is actually always encrypted by standard TCP-based TLS connectivity, which is nothing different from any other TCP connection behind TLS. But with HTTP3, since this is UDP, we cannot put a TCP wrapper on top of that or do some normal TLS the way we used to do it in the TCP because, well, it is not TCP. So in that protocol, and that being also fully and properly implemented in user space by the web server developers, the web server developers and the client developers as well needed to put the encryption level, the encryption features inside of the protocol. And encryption is a part of a protocol here. This is a big difference from the point of view of how encryption is implemented. And also one of the big reasons why this development of this protocol for different web server technologies is severely more complicated compared to TCP-based protocols.
Yeah. And by the way, because encryption is a part of Quick, it allows it to be a little bit faster when handshaking. Because with TCP, with TLS over TCP, you need to handshake TCP first, and then you need to handshake TLS on top of TCP. That takes even more round trips. With Quick, it's only basically the TLS handshake, which is a little bit modified by Quick, but it's pretty much the same TLS handshake.
Yeah. Okay. And so the nature of how you're ensuring that secure connection is a little bit different when we're using the HTTP3 protocol.
Sorry to interrupt you.
Sure.
Not necessarily secure connection, encrypted connection. There is a bit of a difference between encryption and security. We're talking about encryption.
That's a fair point. Yeah. So establishing an encrypted connection between the two changes a little bit. Establishing an encrypted connection changes between HTTP2 and HTTP3. Wow, that's a mouthful. So let's talk about then what it would feel like. So if tomorrow we woke up and everyone everywhere was using HTTP3 and all of the boxes that make up the internet along the way were sort of fluently using HTTP3, what would the benefits feel like for an end user? So the average person sort of consuming things on the internet, what would that feel like?
This is a very important question. So I would describe it as nothing would change at all. So here's why. HTTP 1, 2, and 3, all the versions have the same semantics of the higher level objects of requests and responses. All HTTP protocols 1, 2, and 3 still have the same verbs: get, post, put, whatever others. And they still have the URLs. That concept didn't change. They have the headers, like the host headers. They have the cookies. They have caching headers. They have all kinds of other headers around that. And also they have the concept of request body. That's what you post to the website. And there is a response body, what you receive from that web application. The types of data that is transferred, HTML or JSON or pictures and videos, same thing. So what changed there between the protocols 1, 2, and 3 is the ways how those semantics are being transferred across the networks. This is why I'm saying when everybody starts using HTTP3 and all the systems around that on the transport level support everything about HTTP3, the applications shouldn't care. We still go to the website. And the browser actually oftentimes doesn't show us if it's HTTP 1, 2, or 3 being used to connect to that website. There's still a website, still a URL, still a host name, and still the same HTML page behind it.
Yeah, that's maybe one of the most elegant and challenging things about this is developing a protocol that's effectively more efficient under the covers, but transparent to the end user. Maybe the curse of a lot of these hard software problems is that if you do the job really well, people never notice that it happened. That's a blessing and a curse in a lot of senses. From a developer's perspective, though, certainly things will change. We touched upon a little bit of those already. What are some of the things that developers need to think about that makes using HTTP3 difficult compared to past implementations of the protocol?
If you mean application developers, then it's very similar. Again,
Yeah.
as Nick just mentioned, it's the same protocol, just different internals. But as for the development of NGINX of HTTP3 and Quick itself, there are a few challenges actually, because as I mentioned before, TCP is all in the kernel, which means it's optimized, it's fast, and we have API for interaction with kernel to make everything perfect and fast. But with Quick, we have to rely on UDP, which was never meant to work like that. Like we have to build an entire new transport protocol on top of UDP. And the kernel API that we have now, that we have for UDP, is not perfect for that. So every now and then we hit performance limits or functionality limits that don't allow us, the developers of Quick and HTTP3, to make the perfect implementation. So hopefully operating system kernels will evolve to accommodate for the new functionality that we need to optimize Quick implementations. And also I want to add on the previous question about the benefits of HTTP3 and Quick. Also, I think that there are two main benefits. The first benefit is that Quick and HTTP3, mostly Quick, can tolerate packet losses. So if you have a network that's not reliable, that with high packet loss rate, that Quick will be beneficial because it can still deliver your information despite something gets lost on the way. It can still, your web page will still reload somewhat, not ideally, but something will happen. Things will not stop waiting for that single packet to be retransmitted, right? And the other thing is client migration. So Quick supports client migration. So when you go to a website on your mobile phone and then you travel to a different place and your mobile phone connects to a different tower, you have a different IP address, and normally HTTP client reconnects again. So you lose all context, whatever was happening before that, you lose that. Okay, but with Quick supports client migration, which means that you can keep on using the same session even though you have a new IP address. That's a very cool feature. Even though, again, we have a few challenges with that, but it's so good, and it's so good for today's mobile phones, for today's mobile networks.
Yeah, I think it's one of those things where a lot of these subtle benefits make a whole lot more sense in an internet where we're relying a lot more on streaming much more data than we were 10 years ago. Certainly, the internet of 1990 can't imagine a world where there's that many, that much data traffic going across for one user session for a video stream or something like that. And so protocols like this develop over time as a result of the changing user need, but also the changing sort of developer architecture support for that. And it's cool to see the amount of collaboration that goes into making this happen too. But these are definitely complicated problems, and there's a bit of unknown area here, right? Like we understand what UDP is because it's been around for a long time, but relying on UDP for these sorts of protocols might come with, on a broader scale at least, might come with challenges that are unanticipated.
The funny thing that UDP was mostly used for DNS. We're basically building an HTTP based on something that was used mostly for DNS, which is a completely different thing.
Yeah. Wow, it's come full circle in a really interesting way.
Yeah, you mentioned a very important thing about reliability between the protocols. And this is when an interesting question comes up on what happens if that UDP connectivity is not working well, when the connection cannot be established there, when the packets are not reaching at all. And that certainly can happen. So in the protocols, in HTTP family of protocols, there are ways and conventions to properly negotiate which version of the protocol will the client and server will be using. And all of the websites and all of the web applications, well, probably all of them, maybe some aren't, but probably all of them are using HTTP 1 and maybe 2 together with HTTP 3. There should always be the fallback into that HTTP 1 protocol. So when we're talking about that reliability of connections and reliability of protocols, we should also be thinking of that as not only HTTP 3 that's now existing in the world, but HTTP 3 in addition to HTTP 1.
Yeah, that degrading of service there. Maybe degrading is probably not the right word, but the ability to fall back on the previous protocol is important because it only relies on one, or we only need one weak link in the chain. One computer that doesn't understand HTTP 3 sort of breaks the ability to have that discussion across the network. And so being able to fall back to other ones is really important. I would imagine the logic that goes into that sort of handshake and like migration from HTTP 3 down to 2 down to 1 is some super interesting code to write as well. And honestly, probably way above my head in terms of software engineering practices. But I find that to be a really fascinating sort of space there. How is that something that, how do you see that sort of making its way to other web servers? Is this something that like the debut of the protocol and the protocol becoming more readily available, in Chrome and NGINX and places like that will sort of influence other builders and companies to adopt HTTP 3?
Yes, there are a lot of web services who are adding support for HTTP 3. In fact, there is this project called Interop for testing interoperability of different HTTP 3 and mostly quick implementations. Because it's a new protocol, how do you test it? Because with TCP, you have a client, you have lots of clients, and you have lots of HTTP clients, but this is all new. So what they do, they connect all available clients to all available servers and see how they work with each other. So this is a great project, and you can see just how many implementations are already available, and the list is growing all the time. So this is indeed a very successful protocol, and it's making its way to the market.
Yeah, that's a really smart idea. One of the things actually I wanted to mention as well, going back to this sort of being a transparent feature for the end user of a web browser, NGINX actually made a demo that shows whether or not your particular setup and browser and connection support HTTP 3 and using Quick, right? So there's a really interesting demo page that I found that's quick.nginx.org, which we'll drop in the show notes, which basically fires up a browser window and attempts to make a connection over HTTP 3 and then tells you if it was successful or not. I think it's really interesting that that's something that is so simple to sort of prove out, but also something that, like, frankly, I think a lot of people don't know that they're already using on some level too.
And I would say that the end user shouldn't care. The end user should receive the high quality experience to get their pages, the well-needed data as fast as possible. How we on the back end of things are doing that is not the worry of the end user. This is probably why now if you open that web browser, you're not actually seeing if it's H1, 2, or 3. It would be more worrying for the end user to see that some of the websites are using one protocol or another. They might think less or more about one or another website, and that might not be the case.
Yeah, and I can't imagine having to explain a brand new HTTP to my grandparents to get them to, check their email and see pictures of my cats or whatever the case may be. So what does the future look like? Is there an HTTP 4? Is that a discussion that's happening already?
I haven't heard any.
No. Because for the previous version of HTTP, there always was a reason. It's HOL blocking from HTTP 1.1 to HTTP 2.0. Then 2.0 to 3.0, again, same problem, but on the transport layer, HOL blocking. Now there seems to be no big issues, except we need more efficient and more reliable implementations for what we already have. So
yeah, that makes sense. I think we tend to develop these things out of necessity and not just because we can think of a number higher than 3.
yes.
And so, as we explore an internet that uses HTTP 3 more broadly, I'm sure we'll uncover things that we can improve on and that may require a vastly new protocol. But it makes sense that it's not something that's in the picture right now as well. So for devs who are listening to this show, if there is I guess from the two of you, is there a call to action or a goal for listeners of this show? What is the purpose of having this conversation publicly?
I would say one of the things for the engineers behind the websites is to make sure that their web infrastructure is properly updated. I'm not saying that they must enable HTTP 3. Maybe yes, maybe no, depending on how their traffic actually goes. Maybe it makes a lot of sense, maybe it doesn't. But what does make sense is to make sure that their public-facing pieces of infrastructure are well and properly updated to the more or less later versions, first for the reasons of security, and second for the reasons of enabling the features if they choose to need them.
Yeah, that's smart. One of those things that keeping yourself more modern tends to help for a variety of reasons. Security is definitely a big concern there, but being able to turn on things as they're needed is a great call to action there. If the listeners to the show are interested in learning more about HTTP 3 or changes in the protocol, where's the best place to go for that?
There is a website of the Quick Working Group.
Sure. Yeah,
it's quickwg.org.
Okay, we'll make sure to drop a link to that in the show notes here too.
Yeah, they have links to everything we are talking about is contained in a few different standards. The basic standard is RFC 9000, which is the quick transport. And then there is one standard for HTTP 3. It's unrelated to Quick, but it's based on Quick. Quick is actually a separate protocol. We can use other application protocols other than HTTP 3 over Quick, although we don't see anything popular now. There were attempts to send DNS over Quick. But,
oh, interesting.
Yeah.
Yeah. Okay. So that's HTTP.
DNS over HTTP 3 then. So can you believe it? We used to send DNS requests over plain UDP. Now we have Quick on top of UDP. Then we have HTTP 3 on top of Quick. And then we send DNS on top of HTTP 3. So how many levels we have?
Yeah, it's turtles all the way down, I think.
Yeah.
What about NGINX? Where can listeners go to get the latest from what NGINX is up to?
We did write a few blog posts that relate to this protocol. We have a couple of more in-depth videos available with presentations about this protocol. As much as this conversation is very useful as the general general set of information, when you want to go deeper into understanding of all the internals, it makes sense to resort from videos into reading of information. And as far as reading information, apart from NGINX websites, I can recommend a couple of other interesting ones. There is a nice one made by the creator of curl from Daniel. We'll post that link there. And there is a good set of information on Cloudflare's website as well. And maybe Roman adds a few more notes, but generally speaking, we'll post everything in the description of this video.
I agree on Cloudflare. They post interesting deep articles.
Yeah, definitely. I can say openly and vulnerably here as a typical sort of end user of web dev stuff. It's not something I had thought about a ton before preparing for this conversation with the two of you. And the amount of information that's available and frankly readable for sort of an average developer was really impressive to me. I felt like I was able to get up to speed very quickly thanks to NGINX and Google and Cloudflare and others like it. So for our users, if they want to chase the two of you down on the internet to talk turkey about NGINX or about HTTP3 or development of protocols, where's the best place to find each of you? Roman, why don't you start?
The easiest is my NGINX email, arut@nginx.org.
Okay, we'll drop that. Yeah, I'll make sure to drop that in the show notes too. Yeah,
I think you'll have it. Okay. Yeah. Also, if you or any of our listeners have any question or about using NGINX, using Quick, or developing NGINX, we have a few mailing lists, NGINX mailing lists. You can write any questions you are interested in, and we will answer. Or if you want to participate in NGINX development, send your commitment, your patches, you are always welcome. Again, mailing list is our primary channel of communication with the community.
Sure. Yeah, thanks so much. And Nick, do you have a best place to find you online?
Yes, I usually post the ways to find me on my homepage, which is shadrin.org. We'll post that one. It's a very, very easy URL. If you can see my last name somewhere, that's .org. And whatever. Well, the systems to contact people, they are changing all the time. That's why I chose to post my current contacts on the same spot on the internet.
Yeah, beautiful. Well, thank you so much for joining me today. It's been a pleasure talking to you about this. Definitely a fascinating area of development for the internet and sort of the underlying infrastructure of what we all depend on for sharing information. Roman and Nick, thanks so much for joining today. It's been a real pleasure. We'll hopefully talk to you again soon.
Thank you so much.
Thank you.
All right, take care.